So I'm Jeff Chapman. I'm the field CTO at Vectara, and it's a real pleasure to be here. I appreciate the turnout. My compliments to the AI conference team. It looks like they did a good job. I got everybody here, so I'm happy about that. So I recently joined Vectara. It's been an excellent journey so far. And prior to that, I had some key roles at some fantastic companies. Most recently, I was the CTO, UBS Wealth Management. And prior to that, I was the retail banking CIO for ING. So I was helping oversee all the IT for 12 different banks in different countries across 3 continents. And I've also worked at Capital One leading their enterprise architecture and enterprise data. So you can tell that I'm very passionate about solving problems. And now at Vectara, I have the opportunity to help enterprises get the power out of generative AI for their solutions. So I'm very excited about that. So in terms of the potential is really huge, and we're seeing it everywhere. So that's why I like to say it's raining AI use cases, or Gen AI use cases, hallelujah, because there's just so much benefit that we can bring to the market. And we're looking forward to introducing you to how our tools work, and we'll get to more about how it all happens, and more specifically, how we help companies roll out their solutions without hallucinations. So with that said, I'll have Ofer introduce himself.
Yeah, hi everyone. Glad to be here today. Again, what a great event. About me, I'm a head of developer relations at Vectara, and I live in Silicon Valley, and I've had a number of roles in different companies. One of the things that I got fortunate enough to actually get introduced to large language models when GPT just turned from 1 to 2. So I got a lot more experience than probably most in this room, probably not all, but there's maybe 1 or 2. But 2019 is when I started looking at this technology. And at that point in time, of course, nobody kind of cared for the most part. But it was really an interesting journey for me to see how LLMs progressed from GPT-1, GPT-2, GPT-3, and now the GPT-4, and now we have Gemini and all these other Anthropic and everything else. So I got a lot of stories to share. If you're interested, meet me up later on at our booth. I'm happy to share some of these fun stories. But then I'll let Jeff continue here.
All right. So our next slide. Yeah. So first of all, what's a really good example of an LLM hallucination? Okay. So if you put this into GPT 3.5, hey, did Will Smith hit anyone? The answer came back no, and of course we know what happens. Now, I did try this on 4.0 today just to see, because I know somebody's going to do that on their phone. Yes, it does have the right answer nowadays, but the idea is, what is it that's going to come out of your LLM that's wrong? Okay, and we're going to talk a lot more about that. And so why do LLMs hallucinate? Effectively, you can think of a very large amount of compression. So as you're aware, LLMs are trained on trillions of words or tokens, and they only come back as maybe 1 billion parameters or so. So effectively, you've got 1,000x compression, where according to some theories, the most you can compress is the 3x or 5x times before you start losing information. So effectively, there's nothing but opportunity for the LLM to basically make up things along the way or hallucinate. So there's been a very public failure in generative AI, if you haven't seen it. So Air Canada has a AI chatbot, which I'm sure has been fixed. But at the time, it incorrectly told one of the customers that they could file for a refund on a bereavement fare. And that turned out not to be true. And being unhappy about that, this particular customer sued Air Canada and won. And so effectively, we already have an instance here where public companies are being held accountable for the outcomes of their LLM. So I like to call this our scare slide. Yeah? Okay. And so before we get deeper, just real quick about the company. I know you're here to hear about what we're going to get to with Hallucinations, but Vectara's been around for a number of years. We have a number of existing customers, clients, and technology partners, and we've got some luminaries from Google, Cloudera, and Elastic. So we've got some really strong tech that we build into our trusted generative AI platform. And so effectively, what is it? For those that have built RAG solutions, you're familiar with all these steps, and you probably have a number of open source, say, solutions for each of these pieces, and you spend a lot of time, whether that's in your Python or whatever notebook sitting there, stitching them all together and hoping you're going to get an end-to-end solution. So we've done all that pre-integration with some very advanced encoding and embedding models and retrieval models, and our own LLM And effectively, you just interact with Vectara by loading your data with one API and then interacting with a query response in another API. So we're going to get into a lot more technical details how we do that. And this really can accelerate enterprises, because if you built a POC, you can now say, hey, let me see my RAG solution versus another one, meaning ours. You can even compare the quality of those outcomes. Okay, next slide. And I'll now hand it over to Ofer, who's going to give us a lot more technical details. He's the man for that.
Thank you, Jeff. This is great. I assume everybody here heard about RAG, but just in case, I'm going to do a quick run through of kind of how I explain it and why it's helpful for those of you who did not. So it stands for Retrieval Augmented Generation. And it really helps the LMs focus on facts that are based on your own data, right? So you want to point the LM to your own data and say, please answer grounded in this information. So essentially, in a regular LM use, you start with the user query, you send it to the LM, you get a response. It's based on the training set. For example, in sort of the example before of Will Smith, right? Like that piece of information was not in the training set of GPT 3.5. That's why I didn't know about it. So it kind of made something up, right? So in RAG, you take the user query and you go to this thing here called your data. This is like, think of it as a data store or a database of some sort. And you sort of want to retrieve the most important facts out of the data, maybe 5 or 10 of the top most relevant facts to the query. And you tell the LLM, please generate a response, but I'm augmenting your internal information with these facts. Please use these facts and generate a better response that's based on the information in these facts. That's essentially what it is. So you can point it to your own data. It helps reduce hallucinations because you can give it external information like this. Your data remains private. So this is a question I get asked a lot. There's no training involved, no fine-tuning. Your data doesn't go anywhere. It doesn't need to go. And I'll show this in the demo too. It allows you to get citations, which provides explainability. So you can see where the LLM, when it responded, where the RAG pipeline responded, where it took that information from, which is really helpful. So this is a little bit of a deeper version of the slide for the technical folks, right? So this is how, but it's not too technical, it's just how the flows work internally, right? And I'm showing this to also show that RAG is actually not as easy as it seems to do when you build it yourself. Jeff mentioned this a little bit. So you have two flows. You have the blue flow, which is essentially ingest. So you take the data from wherever it is in the source data, and you ingest it into Vectara. And then we take care of the steps that if you build yourself, you have to do on your own. So there's something about extracting text from a PDF, for example, chunking, calling in what's called an embedding model to create a vector embedding for that piece of text, and then putting it into something that's called a vector database. You probably heard about this. And then when you run a query, you essentially get the query in. It also gets vectorized or kind of encoded through the embedding model. And then you run it against the vector database to get the most relevant facts. And I'm missing a couple of details here because there's other things called hybrid search and other retrieval. But just to simplify the slide, think of it as just running against the vector database. You then re-rank the results also to get even better relevance, or sometimes some custom re-ranking. You craft a prompt that essentially says, hey, LLM, here is the question. Here's the context. I provided the top relevant facts. Please generate a response. And then actually, this is something pretty unique to us. We also added some evaluation metric here, which is called HHEM. And I'll show you that later on. It's a hallucination evaluation model. It's something that looks at this response generated by the LLM and says, is this really hallucinating based on the facts that I just retrieved, based on what it's supposed to be grounded on? And it gives you a score whether it is or not. So I'll show you how that's useful. And after that, you send a response back to the user, and they see it on the UI, and they're happy with that. I think there was a question, but do you mind if we take the questions at the end, or you want to do?
Overlap between the enterprise data store and the data that LLM was trained on.
And between the enterprise data, so the enterprise data store, you take this and you ingest it into the system. Now again, this system could be on your VPC, it could be on-prem, so it doesn't have to go anywhere. But you choose as a developer building a RAG system with this, which data you want to go into to do this.
Hopefully this is still on. To answer your question, so we're not training the LLM on your data. As a matter of fact, we want to avoid that because We want an LLM that's specialized within our entire system to be giving you accurate responses. And so the idea is, since you're sourcing your data at runtime effectively for the RAG solution, we're going to be able to give you answers coming from your data, but not trained on your data.
Yeah.
So we can get into the finer details of, do you want to do fine tuning or not? But we think you don't need to with this approach.
There's no training involved here, which is actually a big advantage. So I want to touch on a couple of, before I go deeper into hallucinations, I want to touch on a couple of things of something we see a lot in the market, which is people move from a kind of a POC stage to kind of an enterprise deployment. And so what happens a lot is that, the realization lands that this is actually not as easy as it may first appear. And so a couple of things we see that are challenges for people doing this transition is, one, you still, in enterprise, you do want to have these citations. It's almost mandatory for people to see where the data comes from and whether we can trust it or not. And of course, to have mechanisms to detect and reduce hallucinations, because that's absolutely necessary in enterprises too, especially in regulated industries like financial services or healthcare, et cetera, or insurance. Enterprise security and privacy is key and almost like table stakes. So you got to have your encryption in transit and in storage, and you have to have SOC 2, Type 2, and all the other things that you need to have. And again, our platform supports all of that because it's almost mandatory to even enter into enterprise deployment. Scale becomes an interesting thing, right? Things that work at low scale, like 5 or 10 or 50 documents, end up not working as well when you have 100,000 or 1 million documents. And this is not only systems engineering things where the latency becomes, a problem or things like this, but also the quality of the results. Retrieval is much harder to do right when you do it at scale. So, people think about the generation and the retrieval of the vector database, but honestly, you need a lot more in the retrieval engine to make it work, because what happens is, imagine you have 10 documents and you have a query. The amount of chunks of text or pieces of facts that you want to bring in from your retrieval engine is pretty limited. I know, maybe it's 100 or 200 or whatever. But when you have 1 million documents, sort of the competition is much higher. So you have a lot more things that might compete to be in that top 10 RAG facts. And so getting that retrieval, that accuracy is really, really key. And it gets harder to do right. You want to put in some guardrails. You want to put in things that protect against not safe at work responses and things like that. That's really important too. And as I said, being able to deploy this with all those features, with the security, with all those things that come with the full stack on a VPC or on-prem is also kind of mandatory. And last, I want to say, people build, but then you have to also think about, who does your production application support? Like, if something goes wrong, is it a vector database you have to check? When you build it yourself, you have to figure out all those different pieces. And it's unclear sometimes where the problem is. So having one coherent system that works together and you can get this support being done properly is really key as well to succeed in a project overall. All right. So that's kind of what RAG is. That's what enterprise RAG looks like. Now let's talk about the hallucination part. I think this is a really interesting thing and a really important thing. And Jeff mentioned a couple of good examples. I want to share with you this kind of a new slide that I put together for today, which is we're starting to do research about categories of hallucination. So originally people think about, I hallucinate or I don't hallucinate. But when you go down to the details of it, you see there's a couple different categories of hallucination. So here's one suggestion of such a kind of a classification. So I'm talking about unwanted. So this will be a summary that doesn't make sense to me. I don't want to see it. It's wrong, right? You can also have an hallucination that's kind of benign. It's like, it's not too bad. Yeah, it's not in the original kind of source information, but it's not wrong either. So as an end user, my experience, like, I don't really care that much about it, as opposed to the more unwanted category. And it's questionable, where it's like, yeah, I'm not sure it's a good summary. So let me give you an example, right? So goldfish are being caught, weighing up to 2 kilograms, and koi carp are up to 8 kilograms and 1 meter in length. And then the summary might be, goldfish are being caught weighing up to 2 pounds and 1 meter in length. So if you read this carefully, clearly that's unwanted. It's really wrong. It takes a bunch of numbers and changes the sort of the pounds to kilogram. It's wrong. Now, if you look at the second one, I ate a lot for lunch and overeating causes obesity. Yeah, I mean, overeating causes obesity is not sort of a fact that's in the source, but it's kind of related and it's not super wrong, right? So it's kind of something that, kind of an example of something that users might actually be okay with. And then this is where it's questionable, right? The train was late by 2 hours and 45 minutes. The train was late by almost 3 hours. So am I considering almost 15 minutes, or maybe almost for me is 1 minute? So it's, you know, people might have different opinions about this. This is where it becomes kind of questionable. All right, so that's kind of a little bit of, you know, the complexity of hallucination detection is that it's actually a really complex problem. And then what I wanted to share with you here is that we've actually, at Vectara, we do a lot of research in this space. We have this model that was shown on the previous couple slides before called HHEM. It's the hallucination evaluation model or detection model. And it's a really useful model. What it can do, it can take kind of the source context in your RAG pipeline and the summary and tell you whether or not this is hallucinated, or it gives you a score between 0 and 1, how much it thinks it's likely to be a hallucination. And so it's a very popular model. We have it in a platform, of course, in a commercial strength, but we also open a very good version of it, just it's limited, I think, just to English or something like that, as open source on Hugging Face, so you can go check it out. This is the model. We also have a leaderboard. So what's interesting about when you have a model like this is you can actually evaluate the likelihood of any LLM doing hallucination on some data set. And so you can see here, these are the top models right now on the leaderboard, where we keep evaluating new models as they come in and kind of measure their likelihood. And this could be interesting. If you pick a model you want to use for your application, you might want to use one that's kind of top on the leaderboard. It's not one that's at the bottom. They're not all the same. I didn't have enough space to list, 50 of those here, but there are some that are like at the 10% or even 12% hallucination rate. It's not, not all of them are as good as these ones. All right, so let me show you a quick demo. This is an application that we've built with Vectara. So in this application, again, we have the ingest flow and we have the query flow. So the ingest flow is we have these news sources. So every day there's a process that goes and crawls all the news sources in these sort of shown here. And the data is ingested into Vectara. And then this is the UI. So for example, if I ask, should artificial intelligence be regulated? This UI will call the query API underneath and give us the response. It's just a very fancy, kind of nice UI to show that. What you can see is you see the response, which was generated, and that's good. And then we have these citations, right? So as you read this, you say, oh, this information was taken from here, so I can click on this and kind of find more information about it and click on this thing and go to the source and see where it was, etc. So it's a very useful way to sort of understand and create more trust that this is not just, I don't know what it is, the LM just spewed it out and I don't know if it's good or not. You can actually kind of check and get more confident as an end user to see that this is a good response. And also I mentioned HHEM, so this is the kind of the platform returns our own sort of internal version of HHEM, and the high confidence here is it's measured already and it shows to be a really relatively high score. So we show this badge, it shows that it's a high confidence result for the user. So this is how you can use HHEM in an actual production application, right? All right. So I'll go back here. All right. So talk about hallucinations. Hopefully this was useful to learn more. And again, you can come ask me later in our booth if you have any questions about that. I wanted to show you one more thing, which is really cool. So there's a kind of emerging thing. You heard about it probably in other talks earlier today. And I heard it also in the the Optum United Health one, about agentic RAG, a really kind of an emerging field, but really cool. And the thing about agentic RAG is that, related to hallucination, is that, and I'll show it in a minute, is reducing hallucinations matters even more in that space. And I'll share with you why. So this is what agentic RAG really looks like. You have a user query coming in, and in this case, you have what's called an agent, or a kind of the brain of the agentic RAG that does all the work. So it's provided a set of tools. A tool could be a Vectara RAG tool that calls Vectara and gets a response, like I showed you in the sort of the flow. But it could also be calling an API that you have internally in the company, or an external paywalled API or something like this. You can also call a database and actually run a SQL query on it. So it's really anything you want to define as a function. And what the agent does is, given the user query, it actually analyzes the query, sometimes breaks it down into different pieces, and decides how to answer this query given the tools that it has. So you can call one or more of these tools, combine the answers together, and usually it does it in a step-by-step way. And this is where you understand why hallucinations might be problematic, because if step number 2 hallucinates and you have 5 steps, you're kind of compiling the error over time. So it's really, really a problematic situation. But once it gets all the responses, it kind of brings the information together and kind of responds back together. Vectara Agentic is a package we've built. It's open source. You can look at the code, but you can use it. Mostly you probably want to use it, which is just pip install Vectara Agentic. I gave a link to the documentation here. And you can build very complex agents too, but I just, for one slide, I shared here like a one-liner, which is one of the most simple way to use it is you take a RAG pipeline in Vectara and you wrap it around with an agent, which helps it achieve a little bit more superpowers. And so this is how you do it. You just give it your Vectara customer ID, the corpus ID, which is kind of the equivalent of an index, the API key, a couple of information about your agent, and you get an agent you can just chat with right away. So it's really, really cool to do it that way. And then I want to show you this demo. So this is, and we call it an EV assistant. So it's a demo about electric vehicles. And what we did here is we created 2 Vectara corpora. One with information, general information about electronic vehicles from Edmunds.com and all kinds of websites for the government about EVs and things like this. The other one is around regulations and laws around this area of EVs. And the third component here is a tool that's not calling RAG Vectara, but is actually, we gave it a bunch of tools on a database that essentially has 3 tables with information about EVs, how many registrations you had per county, all kinds of things like this. This is only for the state of Washington. This is why I'm going to ask questions about the state of Washington, but just, you can do, of course, you can generalize it to whatever you want. And so if I try to click on this, I'll make it a little bit bigger here. So let's imagine that I ask this question, for example. So what is the difference between BEVs and PHEVs, and how many registered in the state of Washington in the past year? You go click on this, then it goes and does its thing, and it'll show us its response in a minute. But what I want to show you is actually, we have built here logs to show you afterwards, like what really happened underneath the covers. And this is the really cool thing. I always get excited when I show this demo. So first of all, you can see that it gave you some information about BEVs and PHEVs, which was asked, and then a breakdown of different numbers of registrations. But how did it do that? So this is the cool part, right? Okay, I have to scroll up here. So this shows the steps, kind of what happened underneath the covers, right? So it got this question, then it called this tool called Ask Vehicles, which is a Vectara RAG tool that it got access to, with this question, difference between BEVs and PHEVs. So first you see already, it kind of analyzed the original question, and broke it down to 2 questions kind of, and removed the what is, and just said, this is the query I want to use. Okay, great. You got a response pretty quickly with some citations and references, kept that on the side, and then it said, okay, I have some tables. Let me see if I can get some information about the more, quantitative question, right? So it did list tables, which was a tool. The tool responded, I have 3 tables: county registrations, EV population, EV registrations. Okay, so I'm gonna pick. This is the tool. All did this himself. There's no information we gave the tool about what's there, just the tools. So then it decided to run this thing called describe tables with the EV registrations table. And the thing they got back is a list of the fields and their type, right? Which is great. And then it loaded some sample data to see what types of values you have in each column, just to kind of get a sense of that. And then this is the coolest part for me always to show is it actually crafted a whole SQL statement to solve the question that I asked it, right? Which is how many, and it kind of did everything with count star and the from and the where, and got the state right. I mean, the group by, all this stuff together, got a response. And based on that response, and this is all the logs, I'm going back from the logs, it took both information from both tools and created this final answer, which it showed to us as the end user. So this is really, to me, really incredible. It can combine both RAG and statistical analysis. Very powerful. And yeah, I encourage you to try it out. I love this stuff. Right, so that's all I had to share today. Thank you for listening. I want to leave you with, thank you. Thank you, Jeff. I want to leave you one more thing is like, first of all, where is this? We have our information here. So either catch us this afternoon or tomorrow at the booth. We're here to answer any questions. You can connect us on LinkedIn or follow us on Twitter. And then I want to leave you with three things to remember. One is, Vectara is RAG as a service. We do really well with, accuracy, reducing hallucinations, security, explainability, which I've shown you, and production support. Those are really important for enterprise deployment of either RAG or agentic RAG. And yeah, thanks for listening.
Yeah, thank you, Ofer. And thank you, everyone. And yes, please stop by our booth. And yeah, we're handing out T-shirts if you come by. So.
And if there's any questions, we can answer some now.
I think we have time for maybe one question.
Okay.
Can I ask several? Okay, well, just clarification, really quick. Do you use your own, did you build your own LLM or you use somebody's LLM? That wasn't clear.
Great question. So we have built all the components in what I've shown in the diagram ourselves, including the LLM. Now we, as a platform, we allow optionality. So you can choose whether you want to use some LLM that you have or that you have some from another place.
So I can bring in
So we're
my...
agnostic to the LLM, but it's a good question because we do have an LLM called Mockingbird that we released about 2 months ago. Mockingbird is a very good LLM because it runs in our infrastructure, of course, and on the VPC, and it's been optimized for RAG. So if you think about it, GPT-4 is really big.
No,
it does
I got
many
it.
tasks.
So how do you compare with Perplexity?
With second question, sorry, you were kind of crammed this in. Yeah. How do we
It's a
compare?
sub-question. I'll allow it.
Okay, thank you. So Perplexity is a great company. They started mostly as a consumer tool. And they give you the citations. So I think we're very similar in a lot of ways. We, again, focus more on the enterprise customers, and we do a lot more in terms of like reducing hallucinations and all the stuff that I talked about. And so we're more B2B and they're a little bit more B2C, I would say.
Right, you wouldn't necessarily get the same outcomes from Perplexity if they don't have access to the company data, right?
Yeah.
So we're combining what Perplexity has as an experience, but on data that's not in an LLM at all.
They don't have that.
Yeah, they wouldn't have it. Yeah, exactly, because companies want to keep
This
their
is
data
on
private.
your data.
Yeah, they might, yeah.
Yeah. Thank you very much.
Thank you.
Excellent. Thank you, Ofer and Jeff.
Thanks very much.